Good day, students. Today I want to consider a topic titled Equilibrium of Bodies in Liquid. Archimedes' principle states that when a body is totally or partially immersed in a fluid, immersed means when you dip it in a fluid, when it enters a fluid, e.g. liquid or gas, especially when you are fetching water from a well. Let me state it again. Archimedes' principle states that when a body is completely or partially immersed in a fluid, e.g. liquid or gas, it experiences an upthrust which is equal to the weight of the fluid displaced. Any object that is completely immersed in a liquid displaces the volume of the liquid, which is equal to the volume of the object. Upthrust, which is the force, equals to the volume of the object, which is immersed in the liquid, times the density of the liquid, times the acceleration due to gravity, represented by small letter g. Let's see what's on the board. It states that when a body is totally or partially immersed in a fluid, e.g. liquid or gas, it expresses an upthrust which is equal to the weight of the fluid displaced. Any object completely immersed in a liquid displaces a volume of liquid equal to the volume of the object. The upthrust is the weight of this volume of the liquid, and is given by upthrust, which is then as force. The unit of upthrust is Newton and unit of force is Newton, equals to volume of the object immersed times the density of the liquid times acceleration due to gravity, where g is acceleration due to gravity. That's what this one stands for. Now, what we are saying, the reason why we say that upthrust is the weight of this volume of liquid is when you have a container and you have a liquid inside it. You know, when the object is being dropped here, upthrust moves up. There is upthrust. There's a force that goes up when the object enters the water, especially when you are drawing water from the well, and the weight acts down. The weight acts down. This is the weight of the object acts downward, and the upthrust acts upward. That's why we say that the upthrust is the weight of this volume of the liquid. Now let's consider this question. An object of density 15 grams per centimeter cube. Now what you notice that these are the units are not standard. We have to convert all the units to standard units, SI units, because you can see that you have to look for tension in string in Newton. This one is standard unit. All this one are not standard. Now let's convert it. Density of object, which is 15 grams per centimeter cube. Let's say weighs 100 grams when suspended. Mass of the object, let's write the parameters as 100 grams. Lower into a liquid of density of liquid equals 0.9 gram per centimeter cube until 2/3 of its volume is immersed in the liquid. Okay, calculate tension in the string. We're looking for tension in the string. Okay, now what we need to do is to convert all this unit. You have 1 gram. See that we have gram. We have to convert it. Let's start from 1000 gram to 1 kilogram. Now 1 gram here, 1 gram to what? That's to x, which is because 1 gram times, you cross multiply like this, 1 gram times 1 kilogram divided by 1000 gram. Gram cancel gram, you are left with 1 over 1000 kilogram for the gram. 1 gram here. Now let's go to 1 centimeter, 100 centimeter, because we need to convert the centimeter cube. 100 centimeter to 1 meter. Now this 1 centimeter to what? X. Just cross multiply likewise. 100 centimeter times x equals 1 centimeter times 1 meter. Divide both sides by 100 centimeter. 100 centimeter. Cancel each other. Centimeter and centimeter. We are left with 1 over 100 meter. Okay, since you have it like that, and you know that we have 3 of the centimeter cube, this one can still be written like this: 15 gram over centimeter cube. Okay, that is, in this place now you're having 15 times 1 gram over centimeter cube. We have already analyzed this one. 1 gram to be equivalent to this, and centimeter cube, there are 3. Now you have 1 centimeter times 1 centimeter times 1 centimeter. It means that you multiply these 3 times. 1 over 100 times 1 over 100 times 1 over 100. Okay, in meter cube, which is equals 1 over 1 million meter cube. Has been converted now. Now let's now join these 3 together. You don't forget that this one stands as 1 centimeter cube, which is for this centimeter cube. Okay, let's put like centimeter, 1 times 1 times everything is centimeter cube, which is for this, and 1 gram, which is for this. Now let's bring the 2 together. 1 gram over centimeter cube is equivalent to, you take this 1 gram stand for the whole of this, which is 1 over 1000 1000 divided by the down one, which is this centimeter cube for this, which is over 1 over 1 million, and this one is in kilogram. It is per meter cube. Okay, now let's now convert it. Equals 1 over 1000 divided by 1 over 1 million equals 1 over 1000 times, when you change division to times, the denominator goes to the numerator. 1 million over 1. Don't cancel this. You are left with 1000 kilogram. You can see kilogram per meter cube. Kilogram per meter cube. Now our density now is density of object equals, it will now be expressed as 15 times 1 gram per centimeter cube, which is equal to 15 times 1000 kilogram per meter cube. And density of liquid likewise, which is 0.9 times 1 gram per centimeter cube, will be equal to 0.9 times same thing 1000, let's say, which is equivalent is 1000 kilogram per meter cube to the standard. Now, what we need to do, the mass of the object is not standard. Now, don't forget that 1000 gram make 1 kilogram, and if that should be the case, 100 gram to how many? X. You now have X 1000 X equals 100 divided by 100 times 1 divided by 1000. 1000 cancel each other. Okay, now your X now equals 0 cancels 0, 0 cancels 0. You are left with 1 over 10 equals 0.1 kilogram. 0.1 kilogram. Okay, now your mass now equals 0.1 kilogram. You need to get the weight. You need to convert to the weight, and don't forget that weight equals mg, and you are giving g to be 10 meter per second squared. 0.1 times 10, which is 1 Newton. The weight is 1 Newton. And don't forget that we need to get the volume, because in the formula for the upthrust, because volume of object in mass times density of the liquid, we need to get the equivalent volume. And don't forget that our density equals mass over volume. You cross multiply, you have density times volume equals to mass divided by density. This is the density of the object. Mass of the object, volume of the object. Now let's analyze it like that. Whereby density of the object cancel out. Volume of the object is, what's the mass of the object? This mass of the object, which is 0.1 divided by density of the object, you are giving as 0. This density of the liquid, density of the object is 15 times 1000. Okay, that's is equals to 0.1 divided by 15,000. When you divide it, density, the volume of the object, equals, when you divide that, you have 6.67 times 10 raised power minus 6 meter cube. Okay, that's volume of the object. That's volume of the object that you're having here. But in the question, we have to look for, it said, if it is then lowered into a liquid of density 0.9 gram per centimeter cube until 2/3 of its volume is immersed. Okay, 2/3 of its volume is immersed. Let me say you're having a container like this. 2/3. This 2/3, 2/3 is immersed. And we must get the volume of the object that is immersed in the liquid. We are concerned with that. 2/3. We now said that volume of the immersed object equals to 2/3 of the volume, of the object. In that case, it will now be equal to 2/3 times volume of the object, okay, which is 6.67 times 10 raised power minus 6. When you press your calculator, you have 4.4 44 times 10 raised to power minus 6 meter cube. That's volume of the immersed object, which is standing for this. And density of the liquid, we have that density of the liquid, you can see it, okay, but we have converted it to this value. Now let's go back to our volume, our formula to get the upthrust. Upthrust F equals volume of the immersed object times density of the liquid times acceleration due to gravity g. Now our upthrust now, what's volume of the immersed object, which is 4.44 times 10 raised to power minus 6 times density of the liquid, which is 0.9 times 1000 times 10, so due to gravity. When you multiply that, you have, you have 4.44 times 10 raised to power minus 6. This one times 9 over 10. Decimal is 1 times 1000 times 10. 0 cancels 0. You are left with 4.44 times 10 raised to power minus 6 times 9 times 10 raised to power 3, 10 raised to power 3. Now, which is equals to 4.44 times 10 raised to power minus 6 plus 3 indices. Now you are having 4.44 times 10 raised to power minus 3. So 4.44 times 9 times 10 raised to power minus 3. Let's multiply this. Okay, you now have 4.44 times 9. 4 times 9, 36, 3. 4 times 9, 36, 37, 38, 39. That's 36, 37, 38, 39. Okay. That's 36, carry 3. 36, 9, carry 3. 36 as 9. Now you shift how many times? 1, 2. 1, 2. Okay. You now have 39.96 times 10 raised to power minus 3. That's in Newton. Okay. Now, based on that, is our upthrust. This is our upthrust. Upthrust is this value. Now we have to look for the tension. And don't forget that our weight is what's our weight? Our weight is this value, 1 Newton. We can still convert this one, you can shift it to the front, because this is 1, 2 to the front. If you shift to the front like that, our upthrust now equals 1, 2. That's 0.039 3996 Newton. That's the upthrust, approximately 0.04 Newton. That's the upthrust. When you shift like this, 1, 2, 3, as you're having 0.0. Is that okay? 0.000. Okay, 1, 2, 3 point. You now cancel this one out. Is that okay? We want to limit the rate at which we use calculator. Now you now have one, you approximate this to 0.04. Now to get the tension now is equals to to get the tensions, the weight of the object, in air minus the upthrust. Now tension now equals 1 minus 0.04 Newton. Now let's do the subtraction. 1.00 minus 0.04 plus 1, 10 here becomes 6. This one remain 9. That's 0.96 Newton. Okay, this is the end of our class. Please subscribe to my channel so that I can have access to the latest video. Have a wonderful day.